Probability of compound independent events. Peter randomly draws two cards from a standard deck of 52, one at a time after replacement. Find the probability that the cards are drawn in the following sequence. So the first sequence given to us is probability of getting diamonds followed by spades. The second one is probability of diamonds followed by not diamonds. And the third one is probability of drawing a king and then a picture card, right? Now this is an example of independent events. Why? Can you tell me that? It is independent event since we are doing replacement of the card. So when you draw a card from a deck of 52 and then you replace it back into the deck, then second draw is like an original draw, right? So it is independent of the first draw of cards. Nothing changes. So it is independent events. I hope you understand that point. If we don't replace, then it is dependent events. The probability in the second draw will change if we don't do replacement of that card. Okay? So that is the difference between dependent and independent. So in this example, we have independent events since we are replacing that card which has been drawn, right? So when we say after replacement means the same card is put back into the deck. That is what it is. Now, let's look into these solutions. First one is probability of drawing diamonds and then probability of drawing spades. So these are two exclusive probabilities, right? So if we draw diamonds, what is the probability of drawing diamonds? There are 13 diamond cards, right? So the probability of drawing diamonds will be 13 over 52. And next time you get spades card. So what is probability of getting spades next time? Will be 13 over 52, right? Because there are 13 spades, right? So probability of drawing diamonds and then spades will be product of these two. So product of probability of drawing a diamonds and then replacing this card and then drawing spades. So this probability will be the product of the two, right? So what is the probability of drawing diamonds? It is there are 13 cards of diamonds, 13 over 52 times probability of spades is 13 over 52, right? Now if you simplify this, you get 13 over 50 is 1 over 4 times 1 over 4 or 1 over 16. So that is the probability of drawing diamonds first and then spades when you're replacing that card which has been drawn in the first place, right? Now let's look into the second one. It says probability of getting diamonds and then not diamonds. So when the events are independent, then the probabilities of compound events is multiplied together to get overall probability, right? This is a compound event since there is more than one event involved. So the first event is drawing diamonds. So probability of drawing diamonds is 13 over 52. And the second one is you do the replacement. That means the card which was drawn has been put back. So you again have 52 cards to start with. It is like an original draw. And now not diamonds. So amongst 52 cards, 13 are diamonds, rest are not diamonds. So the cards which are not diamonds are 52 minus 13, right? And there are a total number of 52 cards. So that is the probability of drawing any other card but diamond. Do you see that? So the first one is 13 over 52 is like 1 over 4 times this is not 1 over 4, right? Not diamonds, not 1 over 4. That means it is 3 over 4. When you do this calculation, you'll get the same result. But that is another way of looking into it, right? Not diamonds. That means 1 minus 1 over 4. You get 3 over 4. You do 52 minus 13 and then divide by 52, you'll get 3 over 4, right? Now when you multiply this, you get 3 over 16. So that is the probability of drawing diamonds replacing it, and then drawing a card which is not diamonds. Now here the third one is probability of getting king in the first place. So what is the probability of getting a king? There are 4 kings in a deck of 52 cards. So it is 4 over 52 times, when the card is replaced, you again have 52 cards, a picture card. Now there are 3 picture cards of Jack. The 3 picture cards are Jack, Queen and King, right? And these are of 4 colors. Rather, I should say 4 suits. Spades, clubs, diamonds and hearts, right? So in all, we have how many picture cards? We have 12 picture cards, right? 3 into 4. So it will be 12 over 52. The 12 picture cards are, we have Jack, Queen and King, right? These are the picture cards and each are of 4 kinds. Hearts, diamonds, spades and clubs. Hearts, diamonds, spades and clubs. Hearts, diamonds, spades and clubs. So in all there are 12, right? So that is how you get it. So you can simplify this and get the answer as 4 over 52 is 1 over 13 and 12 over 52 you can divide both by 3, right? So you can get 3 when it goes into 12 4 times, divide by, rather you should divide them by 4. So 4 times 3 is 12 and 13 is 52 times 4, right? So that is your answer. So it is 13 squared, which is 169. So it is 3 over 169. So it is 3 over 169 as your answer. So that is how you can get probability of compound events which are independent in nature. Why are these events independent? They are independent since we replaced the card in this case. So the second event was really independent of the first one, right? It was as if it was an independent event, as if nothing happened before it, right? So it was the same deck of cards when you replace the card, right? So that is how we have to see this. We'll now do a few examples where the dependent events will be taken into care. Okay, now let's move on to compound events which are dependent. Thank you.